Now we are dealing into solar day. We are dealing into the topics such as the solar day, and then we have sidereal day. Now, what is a solar day? Sidereal day is 23 hours 56 minutes from one point to another, the same point, reaching the time that is 360-degree, right? So the sidereal day is defined as to rotate from point A and again reach point A. It takes 23 hours 56 minutes. To find the rotation time, we have to take long distance star. The time taken 360-degree rotation is for a 360-degree rotation, but the time taken for the earth to rotate on its own axis so that the sun appears in the same position in the sky. The sun, if you take sun, the sun is here. Initially the sun was here, but the sun came to position B, which is 4 minutes away. This is because 1 degree away. This is because the earth is not only rotating, but the earth is revolving also. Therefore, the time taken for the earth to rotate on its own axis, it is rotating on its own axis. Time taken for the earth to rotate on its own axis so that the sun appears in the same position in the sky. The sun is in the same position. The sun is in the same position in the sky. In the sky. It is what we call it as the solar day. So we have sidereal day is the time taken for a 360-degree rotation from noon to noon. Rotation is called as solar day because the sun must come appear in the same position in the sky. The solar day is the time taken for the earth to rotate on its own axis. The sun appears in the same position in the sky. Now 24 hours it is. Elliptical path of the earth does not matter in the sidereal day or the solar day. The path does not matter, but revolution matters, right? Sidereal day to rotate on its own axis so that the distant star appears in the same position in the sky. 360-degree rotation we are using distant star. Okay, the distant star appears in the same position, but for the solar day the sun appears in the same position. The rotation of the time taken, first we mentioned the time to rotate on its own axis so that the sun or the distant star, right, distant star is for the sidereal days, and then the solar day star, solar day we have sun. The sun appears in the same position in the sky, that is 360 degrees in the rotation. For 361-degree rotation we have the solar day. For 360 rotation we have the sidereal day. The speed of the rotation, the linear speed of rotation, anybody present on the surface of the earth must complete one rotation. Now here it's just a point, so 0 degree. Here it is 515, but in the equator it should rotate faster so that it complete 24 hours, right? 1000 miles per hour. The rotation is faster at the equator, whereas it is slow at the poles. The distance traveled is small, therefore it takes for the same time, therefore we have the speed is less. The distance traveled is small, right? The same time, for the same time you just need to complete 1 kilometer in 24 hours, so you can complete it very slowly, but you have to complete 1000 kilometers in 24 hours. You need to go very fast, right? The distance, and then we have the time is same, time is same, the distance is small, speed is less. Time is same, the distance is greater, speed is more. This has an important application in the space science, particularly this is an important in the rocket launch. The rotational speed is important for, we say that the rotational speed, so we can say that the rotational speed is important for the rocket launch. So the rotational speed is important for the rocket launch. We have the rotation. For the rotation we have a speed, the rotational speed, right? The rotational speed is important for the rocket launch. The rotational speed is important for the rocket launch. Momentum is nothing but the force with respect to movement. Highest at the equator, zero at the poles. we have a force with respect to the movement. The force is also high, right? The centrifugal force, the centrifugal force is higher at the equator. So the momentum is a force with respect to the movement. Is what momentum? It is highest at the poles and it is zero at the equator. Adds on to the speed of the rocket. The momentum is the one which adds on to the speed of the rocket. Launching rocket at the equator, initial momentum thrust is high. As linear rotational speed is high. Therefore, we have less fuel, right? The rotation speed is high, right? Therefore we say, what is rotation? Momentum is nothing but the force with respect to the movement, right? So the momentum is automatically higher over here. That is why we choose equator for rocket launching. It is going slowly at the poles. Therefore when you launch, you do not get a natural extra force, right? You have to apply force on your own to push when it is going slowly. When it is already revolving at a high speed, you have momentum, that is force with respect to the movement. You have a naturally higher momentum. Therefore you need to give lesser force for completing the revolution, for escaping from the earth. This is used for rockets, momentum. Best rocket launching center is Coro in South America. In South America's French Guiana country. Clear launch trajectories from the pole and geostationary orbital. The linear speed of the rotation is maximum along the equator and decreases in increasing altitude. This is why satellites and other space missions are launched close to the equator, so that it provides an initial thrust. No rotation for half of the Earth. If there is no rotation, half of the earth will have entire light and half of the earth will have entire darkness. Circle of illumination. We have angle of incidence. The sun rays are making with respect to earth decreases as we move away from the equator. The angle, this is 90 degree, the sun is making. Here it will be 60 degree. Here it is maybe 20 degree, right? Here it is not, at some place it is not even making an angle. Higher the angle of incidence, greater the intensity of sunlight. In 90 degree only we will be having direct sunlight. The circle of illumination divides the region of day and night of the globe, right? Sun is having rays over here, so this is the rays. Now this area is illuminated. This line, entire circle will form, right? This is what we call it as a circle of illumination. So we have the circle of illumination. The occurrence of day and a night is important application of the rotation of the earth. The angle of incidence of the sun rays decides the intensity of the sunlight near the surface. Angle of incidence decreases as we move from the equator towards the poles. We know what is called a circle of illuminance. Let's see. What is circle of illuminance? We have the sun over here. We have the earth and it is tilted, right? Consider this as the earth. When sun rays are falling, right? When the sun rays are falling, this part will get light and this part will not. This entire part is getting will get sunlight, whereas this is the axis, north pole, south pole. This is the axis, north pole, south pole. This entire part, here we have a circle, right? This is what we call it as a circle of illumination. It divides the region of the day and a night. The circle of illumination is for dividing the regions of day, and then we have the night on the globe. Occurrence of day and night is the most important application of rotation. And the angle of incidence of the sun rays decides the intensity of the sunlight. We have the angle of incidence is usually more at the equator and it decreases as we move towards the poles. Revolution. Now we have January 3 and July 4 for revolution. Aphelion and perihelion. In January it is close 147 million kilometers, and in July it is 153 million kilometers. So January 3, July 4 is aphelion and perihelion, right? 3 is perihelion and July 4, January, July, exactly 6 months away, right? So 3 and then we have the 4 is first we have the closed one, closeness is what we call it as a perihelion, and then we have the aphelion, right? Now let us see what is aphelion and perihelion, right? Elliptical path, the sun is not at the center. Why the sun is not at the center? Because we are having an elliptical path. That is why we have the sun is not at the center. Okay. At an elliptical path, the sun is not at the center. Right. Therefore, we say that the revolution is the movement of the earth around the sun. January 3, we will be having the perihelion, which is closer to the sun. Because of the elliptical path, the sun is not at the center. From northern pole of the sun, the earth revolves around the sun in the anti-clockwise direction from west to east. One revolution is 365 days. 1 by 4 is 5 hours 48 minutes. Linear speed of the earth's revolution. Approximately 1 lakh kilometer per hour. In space we are not able to realize because of the gravity and we are so tiny. Earth is revolving at a very great speed, but we are unable to realize that speed, feel that speed, because the earth is having gravity and we are so tiny. Linear speed of the earth is the earth's revolution around the sun is not uniform. Near the sun, more gravity, more speed of revolution. Farther from the sun, less speed of revolution. So we can say that elliptical path, right? We have an elliptical path. Elliptical path is present, and then here we have the sun, right? Or let us move the sun even nearer. This is January 3 and this is July 4th. So in January 3, nearer the sun. So nearer the sun, more gravity. When there is more gravity, the speed of revolution is more. More gravity, the speed of revolution is more. When there is a less gravity over here, less gravity, the speed of revolution is less, but the distance is just very small to notice. Earth is rotating 360 degree around the sun in 365 days. Higher the angle of incidence, greater intensity of the sunlight, right? I think the same page has been come over here. Now we have dealt with the latitudes, longitudes. A great circle was used for the shortest distance. Solar day, sidereal day, sidereal day, right? Solar day, sidereal day. Axis of rotation, the axis of rotation 23.5 degree tilt. Orbital plane 66.5 degree. Angle of tilt and then period of rotation is 23 hours 56 is sidereal day, and then 24 hours is solar day. Linear speed of rotation varies with respect to the latitudes, right? Circle of illumination, day, and then we have the night. Revolution, the aphelion, perihelion, and then we have perihelion, and then we have the January 3 is perihelion, and then we have aphelion is July 4 is aphelion. So we have the gravity, and then we have when the gravity is directly proportional to the revolution speed. Revolution, it's not coming. Okay, gravity is directly proportional to the revolution speed. 181 latitudes are present, including the equator, and 360 longitudes, because 180 east and 180 west. Longitude is the same longitude. 180 east and 180 west is the same longitude. Therefore, we have 181 latitudes, whereas 360 longitudes. 181 latitudes, whereas 360 longitudes, because 180 east and 180 west longitude is the same longitude. Seasons. What is the seasons? The change in the condition of the atmosphere is a season, right? What is a season? The change in the condition of the atmosphere is what we call it as a change in the condition of the atmosphere. Okay, the page is ending there. That is why we are unable to write. The change in the condition of atmosphere is what we call it as the season. The change in the condition of the atmosphere is what we call it as a season, right? Now, cause of the season is not because of the distance between the sun and the earth, because the distance is almost same. Just 3 million kilometer is very small. Okay, the reason for the seasons is because of the tilt of the earth, and because of the revolution, because it is revolving. But the major reason is tilt. Three important conditions: the rotation of the earth, the tilt of the earth axis of rotation, and revolution. It is causing the length of the day because of variation in the intensity of the sun. When there is a vertical rays versus the inclined rays, the vertical rays are giving more heat compared to the inclination. The vertical is giving more heat, which is compared to the inclination, right? So the surface is a larger surface area and more reflection. Vertically, it is having more intensity. If it is inclined, larger surface area, more reflection, but we have less heat. When it is vertical, less surface area, more heat, and less reflection. Rotation, if there is no rotation, no tilt, no revolution, only one half of the earth is going to have full sunlight, whereas the other half is having no sunlight. Rotation alone is there, means we will be having equal days of sunlight, and then we have the night. Whereas there is no revolution and no tilt, there is no seasons, right? Intensity of the sun is maximum at the equator only, right? Length of the day is same for all the latitudes. Because of the tilt alone, we are having equinox and solstice. Rotation, there is tilt, but there is no revolution. The maximum intensity at the Tropic of Cancer. Intensity of the sun is less at the end of the Arctic Circle. North Pole is completely dark, or complete light. South Pole is completely dark. The length of the day, because of the tilt near the equator, we have 12 hours. The tilt is near the equator, we have 12 hours of day and a night. Towards the North Pole, the days are increased. Rotation is there, tilt is there, plus revolution is there. Duration of the day and the night, intensity, Tropic of Capricorn and Tropic of Cancer. Sorry, we have the seasons, right? Are nothing but the variation in the conditions of the atmosphere. The conditions of the atmosphere is nothing but the pressure, precipitation, etc. from one part of the year to another. Seasons are observed on the surface of the earth because the earth revolves around the sun in a tilted axis whose angle of inclination is always constant. The changes of the seasons are mainly due to the variation in the intensity of the sunlight and variation in the length of the day and the night. At particular position, the particular region receives more sunlight for a longer duration, which is called as a summer, and other part of the year receives lesser sunlight for a shorter duration, resulting in the winters. There are 4 seasons. Summer solstice. Summer is 21st June. The summer solstice in the Tropic of Cancer. Sunlight falls vertically at the Tropic of Cancer. The length of the day increases from the equator towards the North Pole and decreases from the equator towards the South Pole. Winter solstice is 22nd December. The sun shines are vertically along the Tropic of Capricorn. The length of the day increases from equator towards the South Pole and decreases from the equator towards the North Pole. Equinox is 21st March and 23rd September. Flowers blossom is the spring. March is spring, and then September is autumn equinox. With respect to North Pole, these are right. Autumn is also called as fall. Flowers blossom. Sun shines vertically at the equator during the equinoxes. Equinox Earth experience equal duration of day and night along all the latitudes. So this is along all the latitudes there is equal day and a night only when the sun is at the equator, vertically at the equator. We need to remember this is an important point. Equal day and night along all the latitudes. That is why we call it as equinox. Equal day and a night along all the latitudes. So we have equal day and night along all the latitudes is what we call it as a equinox. The position of the overhead sun, the place where 90-degree sun rays are falling. Along the Tropic of Cancer, 21st June, Tropic of Capricorn is going to be the 22nd December, Equator 21st March, and then we have the place where 90-degree sun is. Tropic of Cancer is 21st June, Tropic of Capricorn 22nd December, Equator 21st March is spring equinox, and then 23rd September is autumn equinox. The 90-degree vertical sun rays lie between the Tropic of Cancer and the Tropic of Capricorn alone. Earth revolution. Position of the Earth with respect to Sun changes because Tropic of Cancer and Tropic of Capricorn, each places receive 2 days as 90-degree sunlight in a year. Right. It starts from here, it goes a year. But Tropic of Cancer and Tropic of Capricorn receives only one time. This is one cycle, right? Let us talk. Between the Tropic of Capricorn and Tropic of Cancer, they are telling that between the Tropic of Cancer and Tropic of Capricorn. This is Cancer, this is Equator, this is Capricorn, right? It starts from here, right? It goes up, again comes down. This is one cycle. So Tropic of Cancer and Tropic of Capricorn receives the vertical sunrise only one time, whereas the Equator is receiving always. Equator is receiving, not always, it is 4 times. 3 times. 1, 2, and then we have 3 times, right? Now take this place. 1, 2, 2 times it received the sunlight, right? Take this place. 1, 2, 2 times it received overhead sun, vertical sun rays. Take this place, 2 times it received. 1, 2. Equator receives 3 times. Tropic of Cancer receives only 1 time. See, place on the Tropic of Cancer and Tropic of Capricorn receives only 1 time. Polar day, if any place receives 24 hours of daylight. Polar night, if any place is receiving 24 hours of darkness, it would be experienced between from 90-degree north and 90-degree south up to from 90-degree 66.5 degree to 90-degree is where the polar north and polar south, north and south, is being experienced. Polar night, polar day, north and south. Variation in the length of the day and night time from season to season are due to Earth's rotation on the axis is for day and night. Earth's revolution around the sun is for near point and farther point is aphelion. Earth is long distance, therefore doesn't matter. Latitudinal position doesn't matter. Revolution along a tilted axis. Tilt is important. Right, tilt influences the vertical days of the sun. So here they are asking seasons, even the length, variation in the length. The day and night alone is the rotation causes day and night alone, but the variation in the day and night is because of the tilt. But we have here the variation in the day and the night, right? This variation in the day and the night is because of the tilt. Therefore, variation in the day and then we have the night is because of the tilt, and then we have the seasons. Season to season is because of revolution. So tilt and then revolution. 21st June, the sun is 21st June. We say that the sun is summer solstice. Therefore, does not set below the horizon at the Arctic Circle. The sun does not set in the Arctic Circle, right? Below the horizon at the Arctic Circle. Does not set below the horizon at the Antarctic Circle is on 22nd December. Sun size vertically overhead at the noon on the equator is 21st March and 23rd September. Sun shines vertically overhead at the Tropic of Capricorn is 22nd December. Now we have to see the time zones. London sunsets at 10 p.m. The time of the world is not synchronization of the time for trade and travel. We go for different time zones. International time zones: Earth is 24 hours, 12 is east and 12 is west. Standard reference is Greenwich Mean Time, Greenwich Meridian. Along the each meridian of the latitude, longitude, we have the time. Longitude, time is longitude. Every country is having its own standard time. India 28, 82 and a half is 30. 82.30 is the standard time zone, ahead of GMT by 5.5 hours. New York is 5 hours west. New York is in USA, right? 5 hours west. And New York and India is 10 hours 30 minutes, right? IST, International Standard Time, passing through Indian Standard Time. Indian Standard Time is passing through Mirzapur of Uttar Pradesh. Time zones. It's a region of the globe which observes uniform standard time. In this time zone, we actually this is not having uniform. For example, you consider 82 is 82 is Mirzapur, right? Whereas we have 68.7 is Gujarat, right? So here and here there is time difference, but throughout India we are considering there is a uniformity of the time. That is why we have the time zone, international Indian time zone, Greenwich Mean Time. We have time zones, right? The entire globe is divided into 24 time zones. Greenwich Mean Time, Greenwich Meridian is considered as a reference for all the time zones, and from GMT the time decreases towards west and increases towards east. Decrease. That is why west loss, therefore we have to subtract. East gain, therefore we have to add 97.25. International date line. For the date, you have an international date line. It is zigzag to accommodate islands in the Pacific Ocean. Date also, right? So time is related to date, right? Therefore, we have the international date line. International date line is an imaginary line of demarcation on the globe, and it is running from north to south, which indicates the change of the calendar day. It is not a straight line, as it is a zigzag to accommodate the islands in the Pacific Ocean. If a person crosses international date time from west to east, he will gain a day, and he has to subtract a date from his calendar. West it is 12th, means east it will be 13th, right? From west to east means he gains a day and has to add a day in his calendar. From east to west, he has to subtract a day. No, it's wrong. International date zone is in the Pacific, right? So international date zone is different. This is Pacific, then this is Asia, this is Japan. For international date zone, this is west and this is east. So Japan is in the west. Now from west to east he is going, means sun rises in Japan, right? So Japan, if it is 13th, means here Pacific it is 12th. So he gains a day, therefore one needs to be subtracted. From Pacific to Japan, if he is coming, means he lost a day, therefore one needs to be added, right? For international date zone alone, the west to east changes. You have to draw the international date zone before calculating. International, for time we take Greenwich Mean Time, but for international date zone there is a line. That line is passing Pacific Islands. Now here we have the Pacific, and here we have the US. Here we have Asia, Japan, right? Between Japan is where the sun rises. So international date line is between Japan is on the west and then US is on the east. Therefore, gaining a day means one day we got. I mean, if yesterday I get yesterday again, it is a gain for me, right? Idea of multiple time zones. Those countries having wider length, longitudinal extent is very high. Russia cannot have a single time zone. Therefore, when France follows 20 time zones, it is highest, has many overseas territories, because France is having many overseas territories. Right, France is having overseas territories. Therefore, we have France is having highest time zones is France. This is very important because we usually think that according to the size of the country, but France is very small. It's because it is having overseas territories across Indian Ocean, Pacific Ocean. That is why France is having 12 time zones. Russia is having 11 time zones. USA is having 11 time zones. For economic integration, banking must not be disrupted. Railways, security. During the British rule, we have 3 time zones: Bombay, Chennai, Kolkata. Chai Bagan time. Local time in the Assam tea gardens is what we call as Chai Bagan time. 89.52 is a proposed dividing line. East of it is IST2, 1 hour ahead of IST1. Same as existing. Researchers, only 2 railway stations would need to reset their time across. Then in 1906, we have adopted the Indian Standard Time, International Date Line. Date changes, right? It was agreed in 1884. Kept as minimum landmass as possible. Japan is in the east, but no place is having sunlight. West, light keeps on going. For sun, Japan is in the east, but for international date line, see, Japan is in the west and North America is in the east. Lost a day, gain a day. Now, factors which are responsible for the seasons. Earth's revolution in its orbit around the sun, because it is completing 365 days. Inclination, spherical shape of the earth. Summer solstice equinox is just a factor to be consolidated to the earth's revolution in its orbit. Daylight save time. Now, in certain areas, the light comes faster, right? At 6 o'clock itself, because in the Arctic Circle, regions above the Arctic Circle, at 6 o'clock itself, they might have some sunlight. So, the government is forwarding the clock by 1 hour, when it is actually 5 o'clock, but they change the clock to 6 o'clock so that they can save, they can be productive in the office hours are there, right? So they can be productive during the sunlight itself, and they bring it back when the summer is over. During the summer alone, in the temperate region, we have the concept of daylight save time. So during the summer alone, we have in regions they are above the tropics, temperate regions, right? Summer's duration of the time is longer, so 16 hours per day. So the government forwards the watch at 1 hour to bring it back to when the summer is over. Daylight save time is not for India. The practice is in the temperate countries. It's a practice of shifting the time by 1 hour ahead by forwarding the time in the clock during the summer. It is practiced in those regions where the length of the day varies between summers and regions in the temperate regions. Leap seconds. 25 to 30 years, very long time with no uniformity. Time measurement throughout the earth. Earlier we have Greenwich Mean Time. You have UTC, current method, coordinated universal time. So we have coordinated universal time because we are using atomic clocks. More accurate and more synchronous is a precise measurement of the time. We have universal coordinated universal time, CUT. Coordinated universal time. So here we are dealing with a topic called as coordinated universal time. It is more accurate and more synchronous. 2 clocks are there. One is atomic clocks and the other clock is based on the rotation of the earth. UT1 is slowed down by 1 second. For every 25 to 30 years, there is a leap second. Means the earth is slowing down by 1 second. Earth slows down. Therefore, there is changes, right? Whereas atomic clocks are very precise. Every atom particles keep on vibrating in a very precise manner. The clock is based on vibrations. This is based on the vibration of the atomic particles. Coordinated universal time coordinated use synchronization of both atomics, as well as it uses both the clocks. Atomic clocks are also used, as well as rotation of the earth are also used. When there is a variation, we just speed it 1 second, it is slow, right? The earth has slowed by 1 second for every 25 to 30 years. This is what we have, the leap second. So when we found that using the atomic clock, we have to synchronize it by just changing the times in the clock, increasing the time by 1 second, right? Variation with respect to few years, slow down by 1 second, a variation in the UTC, so we need a 1 leap second to synchronize the slowdown in UT1. So add 1 extra second to the atomic clock. Coordinated universal time is based on TAI and UT1. International atomic time, based on vibrations of atomic or molecular systems, UT1 is the astronomical time based on the Earth's rotation. Once in a while, the Earth's rotation slow down and accommodating slow time is used for the so that the Earth catches up. To slow, we need add 1 extra second. It's called as leap second. Atomic clock. This is what, slow by 1 second. Leap second, we have to add 1 second to the this one, right? Then it becomes leap second.